Good afternoon to all from London and welcome to a new webinar hosted by IMO's GloFouling Partnerships. My name is John Alonso and I will be your host during today's event. In today's webinar, we will have a glimpse at a robotic system that combines AI learning to analyze hull inspection data and how this can be applied to biofouling management. We will start with a brief 15-minute presentation to give an overview of the system and the different components. We will follow this with a demo of how the robot performs the hull inspection. And we will end the webinar seeing how the AI system analyzes the data to produce a report. After this, you will have the opportunity to make questions about the system. Please use the Q&A window to send your questions in writing. You can open the Q&A window by clicking on the button on the bottom right corner of your screen. You see it blinking right now. Questions can be sent at any time during the webinar. And at the end of the demonstration, we will give you the floor to make your questions live. And we will try and do that in the same order as we receive the questions. Before we start as well, please let me give you some recommendations. Use the chat box that you can see as well here blinking on the, the button is here blinking, but you'll see it at the bottom left-hand side of your screen. Use the chat to let us know if you're having any technical issues. We will reply to you privately. My colleague Maria Vranik, who's taking care of all the technical aspects of this webinar, she will answer to you. One recommendation, if you're having any difficulty, if you cannot hear me, you'll see in the messages here, I think on the chat, if they let you know if you're not hearing us, we recommend that you disconnect and connect once more. Normally that corrects it. If not, maybe try and check the speakers, how they have been sort of identified in your own Zoom window. And if not, if you still have problems, maybe then contact us through the chat and my colleague, as I said, Maria, will try and help you as best as she can. A very short disclaimer here to remind you that the opinions expressed in this presentation are solely those of the speaker, and it does not imply in any way or form that IMO supports or endorses or validates the technology, services or practices that are going to be sort of showcased in this webinar. So after that, I think it's time to welcome finally our speaker for today, Thibaut Hubert. Thibaut, hello, welcome.
Hello, John. Good afternoon. And good afternoon, Maria. Good afternoon, everyone. Good day, wherever you are. I think we have international attendance today. So really honored to be here. Thank you, GloFouling Partnerships, for the opportunity to present our work on underwater robotics and artificial intelligence.
Yes, thank you, Thibaut. I think it is a great honor as well for us as well to have you here. We're quite excited to be able to showcase this new technology and all the different applications and the possibilities that they have. So just as a very brief background here on Thibaut, he has more than 10 years experience working on the international context on hardware and software technology development. And he is currently the international sales and marketing manager for Nutilo Plus, which is the company that's showcasing, that's helping us showcase their new technology. Okay, so without further ado, let me hand over to Thibaut. And Thibaut, the floor is yours. I think I'll stop sharing, and I think you can take over.
Thank you, John. So let me share my screen. You should have it now.
Yes, we can see you very clearly.
Okay, can you see my screen as well?
Yes, perfect. So
okay,
just
good.
All yours.
All right, thank you. Let's go. So Thibaut Humbert, I'm from Nutilo Plus, International Sales and Marketing. And yeah, like I said, very honored to be here today to speak about these interesting topics we have around decarbonation, the greening of shipping, and what can be done in the hull management spaces. We have several challenges that need to be addressed nowadays. The IMO has set up ambitious goals to reduce carbon intensity by 40% by the end of this decade. and by 50% up to 2050. And we know there's a direct link between high biofouling levels and excess fuel consumption, and therefore greenhouse gas emissions. So whatever can be done at the hull level is helpful towards decarbonating the shipping industry. And also it comes with other benefits, like avoiding ecosystem contamination by aquatic species that can be invasive and predatory in other local ecosystems. And also the pressure from regulations will apply on ship owners increasingly over the years to better their process in terms of hull management. So overall, there is a need for higher quality data-enriched hull inspections, and that's what we are focused on with Nutilo Plus. That also means that we are moving from a reactive approach to a more proactive approach. And that means that the process can change at the data collection level and at the analysis and reporting level, which I will explain during this call. A few words about us, about Nutilo Plus. We are a French company, a little over 5 years old, and our products are used all over the world, not just in the shipping space. We work with academia, we work with marine research, navies, search and rescue organization, offshore and infrastructure players as well. And we have about 500 drones being operated worldwide by our clients. And we are grateful to be also supported in our research and development work by the European Union through the Maritime and Fisheries Fund, as well, and as supported by large industry players such as Bureau Veritas, DNV, and CMA CGM. We have several products, but we'll cover only two today, CSAM and Nutilo Cloud, which are relevant to our topic of the day. So what kind of challenge, more specifically, do we have with hull inspection? First, with data collection. What we have is different players throughout the world who use different technologies and methods to collect hull data. For example, some inspectors use divers, commercial divers with GoPro cameras. Others use ROVs. And then documents of different formats are required by end users. So both the way the data is collected and the way results are presented can be very different from one place to another. A second problem we have is that local conditions at the time of a hull inspection vary widely depending on wherever you are. In Singapore, in Rotterdam, or Long Beach. So the variety of techniques used is large as well to adjust to these varying local conditions. Third, the people and companies who collect data don't have the same objectives sometimes, don't have the same sizes, scope of work. And this also contributes to making all inspection of very different nature with very different reporting. Now, another set of challenges that we have is with data analysis. Today, many operators amongst the companies involved in the hull inspection few of them are specialists of data analysis. They usually don't have a specialist tool for it, and everything is very do-it-yourself. So data comes from very different devices and captured with different methodology. So there's no standardization of the analysis that are done. And the reports are scattered all over the world in different inboxes instead of being centralized. So in many cases, the data of one inspection cannot be reused over time. And so obviously this is of a big concern for large shipping companies who have global operations, but also for regulators. So these are the specific challenges we've been addressing through our work. And before getting into the more details of how different components work together, I have a short 1-minute video to show to you that gives you a brief overview. So that should play now. So what you see here is an operator piloting his ROV to a ship hull to perform the inspection. And this inspection can take up to a few hours. But data is collected in different locations of the ship hull. And after the inspection, it's reported on a platform that uses artificial intelligence to automatically classify all the images extracted from the videos. The platform we develop also then processes this data into reports, into dashboards that can be easily shared because they are digital natively. And the data can be used over time to perform more thorough analysis of the status of a hull. So let me go back to my slides. Now, I would like to show you how a hull inspection is done in reality. And so usually, like I said, it's a 2 to 4 hours process, but we have managed to compress it into a 5 minutes video. So that don't bother you too much and waste your time. So I'm going to comment it. And so what you see here is our ROV kit that has a drone, that has a cable to bring the video to the surface, the operator. You saw the tablet and also the controller used by the operator. It's powered by a battery. The drone is powered by a battery, and you connect the drone to its cable. And you secure it, you secure that cable on the ROV. It's a strong cable, so you can use it to put the drone in the water. And then you turn on your drone, you turn on the tether reel, which has basically a Wi-Fi system embedded for a wireless connectivity with the tablet used by the operator. So the operator prepares his tablet, and the robot is being immersed. So you see, he can use the tether to hold and put the drone in the water, even from a high freeboard. That's no problem at all. The first thing the operator does then is to set up and define the ship is inspecting. So he's going to add the length, the width, the draft of the day, and he also can add where is located compared to the ship, and which side of the boat is currently standing on. This is especially used for using our underwater location system, which is not used every time, because location of the drone compared to the hull can be declared manually. So now you can see the robot is in the water, just under the surface. And that's what the operator sees on its application. Now you see on the bottom left of this application screen that we have a little widget that indicates the location of the robot. And now it says we are on starboard, stern 1 section, which means that all the videos, all the screenshots that are being taken during the inspection in that zone are tagged, are assigned to that starboard stern location. And so now we have moved on to another location. We're on the propeller, and on the propeller, I can decide to make a little clip within my video. It's like a video in the video that I will call propeller. And now you can see that propeller is quite heavily fouled. It's almost a jungle. And so the drone can easily navigate around it because it's very stabilized. And now you see also that my operator has changed the location to port side propeller. He finds then the biofouling very important on this propeller, and he has put a critical flag for this moment, this image of the foul propeller. This flag will be then found in the report of this inspection. And now I'm more like on the propeller shaft, and the operator is using different tools within the application to simplify his inspection. He has locked the depth. You can see on the right hand side, the depth is locked to 4.07 meters. And he has also locked the yaw movement. You see a lock on the top right side of the screen, meaning that the robot is looking at the same direction, and the operator just has to glide the robot from left to right, which really simplifies his work. Doesn't have depth to manage, doesn't have the orientation of the drone to manage. You can also see on the right hand side a wall distance appearing or disappearing. It shows the distance the robot has to the hub. And this distance can also be locked, meaning you can really stabilize your drone in position and remove several degrees of piloting. So that was a brief overview of how the data is captured. And now what I would like to summarize is that basically, in addition to a simple application, there are operating procedures that can be used by operators to ensure quality in the inspection, ensure that most of the ship is covered, and using all the autopilot assistance that is in our system. These inspections are really simplified, whether you're at berth or at anchorage. But that's for the inspection itself. Now, certain decisions need to be made on the spot, and with a digital or robotic process of inspection, the good thing is that you are able to share a video stream. You are able to share information in real time with people remotely. So you could call for a remote expert's opinion about something. You could call for a class expert opinion. And you can also share rapidly some of the key results or key findings from your inspection to the captain or the board that might need and want to make a decision about whether this propeller needs to be cleaned or not, or other decisions. So that's really like a simplified inspection for operators. In my process, in the process that we have developed, the data is collected. What is the next step? The next step is to upload the data onto our platform for further processing, for a deeper and more complete reporting. We've done live reporting and live sharing, but we can do a more thorough analysis on our platform. And if you remember what I mentioned earlier in the problem statements, one issue we have is that data is scattered all over the world with people using different methodologies. So we have need to make this platform interoperable to other data sources in order for inspections to be all centralized into one space, whether the operator locally actually use our device or another. So we've made our platform interoperable for that reason. You've also heard me talk about artificial intelligence. So what exactly are we talking about for artificial intelligence in the context of an inspection? We are talking about large-scale analysis of hundreds of images that are extracted from the video and analyzed by a computer in a very short time. We are also talking about algorithms that have different classification function, if you wish, and that are also built into the system. For instance, we have a visibility classifier that is going to select which pictures are deemed relevant to be analyzed. Sometimes in an inspection, you might see just water or you might see the hull. So in order to have an accurate computing, you need to have a first level of filtering that says, okay, I'm looking at a hull or I'm not looking at a hull. And we have other classifiers like the niche area detection. As you can see on the picture, we can detect a propeller, or we can detect an anode or a rope cutter. And we have also a classifier on biofouling, which I will expand a little bit on. Without being too technical, let's take the example of this biofouling classifier. So first, we have built a data pool of images, and every image in this data pool has been annotated by expert. We use a simple scale from 0, that means clean hull, to 3, which is a critical fouling. In between, you have 1 and 2, which are slime or minor fouling, major fouling. And this group of images serves as a reference for our platform. And then secondly, we have built these algorithms of machine learning that compare each image from the inspection against this image set of reference. Therefore, every image can be analyzed automatically, and a large number of pictures. You can see here, starboard is 1,700 pictures that are analyzed. And the assessment is independent. Once the classifier is ready, there's no more human interaction at this stage, and the assessment is independent. It's really machine-based. And you can have then averages or spreads of these assessments across different locations on the hull, which I'm going to show you now. But first, one of the key questions we are often asked is, how trustworthy is your AI for this scoring? So we have studied the accuracy of the AI by simply comparing the results estimated by the AI as opposed to what an expert will decide. And what we found is that the estimation is the same in 72 to 93% of the time for this classifier of biofouling. It's a good number, and it's especially good number when it's replicated across hundreds of images that are analyzed. And so together, it gives a trustworthy representation of the biofouling levels. Like I mentioned earlier, we have other classifiers that have also been studied. So the no hull classifier, the visibility classifier, has similar result. Same goes with the coating damages classifier. And we have extremely good result in niche areas automatic detection. So the automatic detection of a propeller or an anode will be accurate in more than 90% of the cases. If you're interested in these more technical data, we have a white paper that is available in which you will find all the details, but I won't expand further on that. I think what is more interesting is that I show you now how the platform works in reality. So I'm going to show you Nutilo Cloud. I have opened my browser here and I am connected in my workspace. that is the one of my company, let's say. And what I see is different projects that correspond to different ships. So I have the Dame de Grace ship, the Star Seed, the Hill of Fourvière, and each of these ships might have different missions, different dives, but I have them all centralized in one space. Once the data arrives on my platform, and I can create missions, I can create inspection, and then I can generate report. So if I get into one of these ships, let's say Dame de Grace, I will jump into one of the inspections that has been performed earlier, this full inspection, and I'm going to see straight away my report. It's an interactive digital report, so it takes a few seconds to load, but here is what it looks like. You have an instant view of the level of biofouling on the hull, because all the images from the videos have been computed by the system. You have an overall score here of 0.61 out of 3. Remember, my scale was between 0 and 3. And we can see also that 51% of the images computed showed no fouling. 42%, the yellow bar, show 42% of image show minor fouling, 6% show major fouling, and 0% show critical. You can also see that there are a certain number of coating damages that have been identified. 304 and 138 for mechanical. And then, so that's just the overview. And then you can go down into the different sections of the ship. So I have starboard, where 715 pictures have been analyzed, and port side has 525 pictures have been analyzed. So each section is represented in a colorful way, and I can drill further down into the details. So I can have details by the depth, and so you have more granularity into the data. So I can look at the images around between 4 and 6 meters on midship 3, and then I go into a media view where all the pictures that have been categorized under starboard midship are filed and are in that depth that I specify. These filters I can choose here to I can choose to display different things. It's dynamic, so I can choose different draft, different level of fouling, and I can refresh to see different images based on these filters. Okay, so you can then choose, okay, this image is relevant. You can choose to add it to a report. By adding to a report, I mean a standard PDF report that would be issued based on my that is automatically issued by the system, but that I can edit and correct myself. By correction, I mean that if I disagree with the assessment of the artificial intelligence for the level of fouling in this picture, I can change it here on the right-hand side. I can say, okay, this is not critical fouling. I can say this is only macro fouling, and I've edited this the AI, because as we've seen, it has very good results, but it's not perfect. So you can have a quick review and of the system through here and edit your report. So here I can add a conclusion, I can add text. What I wanted to show you also is a niche area that can be detected. So here my rope cutter has been automatically detected on the port side during the inspection. Same as the propeller. was also been detected. So here again, I can of course zoom on the pictures, and I can review myself what the platform, what the software has done on its own, and this goes for all the sections of the ship. Like I said, this is the interactive digital report, but of course, once it's ready, once the review has been done, you can download this PDF and you can always update it. So here it is, a more standard looking report with the defining features of my ship, synthesis, signature to make it official, and then I find again the key findings of the report, the automatic reporting, and then I will drill down into each and every section and find the pictures that have been deemed very representative for the section. And so, like I said, this can be edited. But this PDF can now be generated in maybe 1 hour versus half a day of work, picking screenshots from a video and being copy and pasted into a Word document or PowerPoint. This is all generated by the system natively, and you can adjust it the way you want. So this is what happens when the data comes from our robot solution. But let's say that I don't have the robot solution of Nutilo Plus. I have GoPro video, historical inspection videos. I can also create a report that uses this platform. So what I can do is I can create a mission. I can define its date, start and end date. Actually, I realized that I've already created a test mission here. And here you can see that my reporting is empty, but I can select from my computer the videos that are relevant. So here I have my inspection videos from a previous ship, and I can choose these pictures and those videos. Of course, I'm not paying much attention to what I'm selecting right now. It's just to give you an idea. And I can upload them into the online report, and they will be assigned to the section that I have chosen here. So even historical data can be reused through the system, or again a more manual process that can be adapted for various stakeholders, whether they are in Abidjan or Singapore or Long Beach. So once this is uploaded, here I have done all the imports. I can do it for different section of my ship, and in this case, I would click Generate Report here, and the same reports as I've shown you before will appear with different colors, different color codes, different biofouling assessments will appear. So that, I think, explains the key features and results you can get with the platform and with the artificial intelligence. I can also show you, lastly, that if you want to look at a whole video, of course, and find your whole videos, you can. And you can straight jump into flags that have been put at the time of inspection. You can jump and navigate your video more easily than doing it manually. And you can also add annotations if you have made a specific finding when reviewing this video. So I think that is it for Nutilo Cloud, the reporting part. You can now also select different users for sharing the reports both digitally and on a PDF basis. This is simplified through the system, and the Nutilo Cloud is always available. It's in the cloud, so it's 24/7. So you have a specialist tool that is always available for everyone. So yeah, to summarize on the cloud part, on the platform part, we automate reports, we simplify the sharing of this information, and we allow a long-term tracking of the result. We allow also a deeper analysis thanks to AI and thanks to a digital first process that allows to sort and filter through medias and through ship locations. And now that we have this, what are the next things that we are considering for our development? We are looking at hull management at scale. We are putting in place dashboards for ship owners or people who want to inspect and gather data from various different sources into dashboards where they can realize the amount of fuel penalty that is generated across one, two, multiple ships. They can see their ship schedules. So the idea is really to have a fleet performance dashboard that will help you decide when and where to clean the hull, make forecasts. And we also have several programs to improve our classifiers, to deepen the analysis, but also to make all these valuable insights interoperable with other sources used by performance manager today's. Many data sources can be plugged together, and ours is one of them, in order to keep moving forward into more predictive and more proactive maintenance of ships. And the last thing we do is we speak like today about our new classification technique, because today the evaluation are done mostly based on percentage of coverage of biofouling on ships, and they don't cater so much for larger image sets. And with our system, we believe that we have a much more comprehensive and independent and transparent assessment of biofouling. So those are the projects we're working on with various players in the industry. We're also part of working groups with the AMPP, NACE, and other industry groups to integrate different concepts into our system, such as other scale for fouling evaluation and so on. With this, I think my presentation is over. I hope it was informative, and I think John,